Synthetic substitution. Synthetic substitution is a way that you can substitute in values ridiculously quick. When you think about the ways that you can substitute in values, what you guys would normally have done in the past is, if you're going to substitute in -2 into this equation, you would write in 2 to the -2 cubed plus 5 times -2 squared plus 4 times -2 plus 8 to figure out, just straight substitution. You'd sit there and you put it in your calculator and go. Well, what's nice is that there's a nice, clean method to do this, and to do this rapidly. So, there's a process. When you have a polynomial, your polynomial has to be in descending order. That's rule number 1. The second rule means that it has to have all possible degrees. So in this case here, I have a 3rd degree polynomial, which means how many terms should I have? 4. I have a 3rd degree, 2nd degree, 1st degree, and a constant, which is our 0 degree. Okay? So you have to have 4 parts here. So long form, we'd sit there, we get -8 times 2 is -16, plus 10 minus 8 plus 8, you wind up with -6. Right?
Yes. Sure.
I hope.
Yes, because 8 cancels.
Right. Using synthetic is even more fun.
I love fun.
What are the coefficients of our polynomial, including their signs?
2.
2, 5, 4, and 8. So I write down my coefficients, like, did I do that wrong?
Huh?
You guys were just looking, I just want to make sure. Okay. Write down your coefficients. And then draw this. It's a little box.
Yeah.
And what are we substituting in? What are we substituting in? -2. Put that out here. You look like you're going to be worried.
I can't do regular multiplication.
Well, wait! All right, ready?
Can't do regular
Drop the
multiplication.
2 here.
What? Why are we doing that?
This is how you do this.
He's showing us the 2.
Like, why don't you just drop the 2? Like, well,
This is how you do these things. The first step.
okay. Just drop the
What's 2 times -2? I write that there. This is how this is just the process works. What's 5 plus -4?
1.
Why?
I'm adding downward and I'm multiplying the outside. What's -2 times 1? What's 4 plus -2?
2.
What's 2 times -2? What's 8 plus -4? I must have screwed something up with the other part here. Oh yeah, duh. That should have been 4. 4 times 5 is 20. So this should have been +4. That's why you guys are looking at me crazy. So my last value here is what it equals when I substitute in. Let me show you another one.
Yeah.
So I have 5x to the 4th minus 8x cubed
Can't sing anymore.
plus 7x squared, and I'm going to substitute in 1. It's a 4th degree polynomial, which means how many should I have? 5 terms, which means I have to find 2 placeholders. Are the first 3 terms here in descending order? Is anything missing? Which means I need an x and a constant. So I pull out my coefficients. 5, -8, 7, 0, and 0. Now, obviously, if I'm substituting in just regular 1, it is pretty easy just to do that in your head. But when we start using the synthetic substitution later on, there's a reason that we're doing this. We're actually, since x equals 1, that means it's the 0. It's the 0 of a term. What's up?
So why do you need 2 zeros?
You have to have everything in a descending order. You have to leave your place values no matter what. Since you have a fourth degree polynomial, you should have 5 parts when you go through it. If it's fifth degree, you have 6. If it's third degree, you have 4. It's just one of those little rules that are thrown here. First thing you do, drop the 5. What's 5 times 1?
6.
What's negative 8 plus 5? What's negative 3 times 1? You guys and your is it always in the answer? What's 5 minus 8? Negative 3. What's negative 3 plus 7? It's another way of doing substitution. It's so much faster than synthetic. Which I know. I like synthetic. It is fun.
Like,
Two x to the 4th minus 8x squared plus 5x minus 7. And we're going to use 3 to synthetically substitute. What I was saying a second ago, this value here is x equals 3. If x equals 3, what would the term be that gave you x equals 3? It would be x minus 3. The term x minus 3 generates a 0 of 3. Does that make sense? Keep that in the back of your mind when you're using synthetic, because that idea here is going to come into huge play when we factor polynomials. Because when you factor polynomials of upper degrees, all you're going to do is synthetically divide, and it is a snap, guys. It is so stinking quick. It's so easy to do. Okay?
Snap.
Is this in descending order?
no.
It is. What's it missing though? You're missing a cube. So when I pull my coefficients out, I'm going to have a 2, 0, negative 8, 5, and negative 7.
Oh, no.
Have to have placeholders, otherwise it's not going to work. What do you do with that first value? Drop it. So you add 2 here. What's 3 times 2? 0 plus 6. 3 times 6.
6. Wait, what?
3 times 6.
What?
10, 30, 35, 70, 105, and then you get 98. Adding and multiplying is something you should be able to do in your head.
I'm not good at that though.
You're going to have to get good at it. Because again, this is going to be that type of stuff that we're going to do that'll have calculator and not have calculator. Okay. So if you substitute in 3 into this equation, you should get 98. Okay? What's up?
Two.
2, 6, 10, 35.
Come on, you should be able to do it. You know how to say it.
2x cubed minus x squared plus 6x. And we're going to use 5 as our 0 to synthetically divide by.
I can hum.
5's on the out. 2, negative 1, 6, and what do I put last? 0. Okay. Gotta have a placeholder. Keep in mind that whatever your degree is, you should always have degree plus 1 terms. Okay, degree plus 1 terms. Don't drop the 2. 10, 9, 45, 54, 0,
Adding them without restriction.
270?
54.
Yeah, it's hard.
Oh.
It is hard. Tell me about it. I could
Where did you get those ties? My son loves wearing ties. But
They're
where's
ties. I don't know.
because my son loves to wear my ties, but they're always too big. So
I feel like they have my wallet.
I gotta-
These are like.
Oh, you gotta learn how to tie. That's a little bit better. I gotta get on the regular tie and actually tie it.
True.
You can tie those.
Well, yeah, I know those are little zipper ones, but I still like them. Okay. Here's the other part of today.
There's more. For real.
Oh no! Adding, subtracting, and multiplying polynomials. Oh no! It's so scary. So scary. So scary.
I know.
It is. It's painful. Oh, the horror. Oh, I can't handle it anymore.
Yeah, for real.
You okay? I'm not like Mr. Seven, you know, a little bit more animated.
Yeah.
A little smidge.
Teach like drama.
So, in this case here, when you're adding and or subtracting, guys, it's just combining like terms. Okay? It's combining like terms. One thing that I would suggest when you read the problems, don't do addition or subtraction horizontally. Rewrite it vertically. Here's what I would do if I were you, and obviously you've probably written down the problem. Put everything in a descending order. So we have 3x cubed plus 2x squared. Notice I'm spacing it out a little bit. And I'm going to line up everything that matches below it. X cubed minus 10x squared plus 8. And I'm adding each one of these because the symbol right there means I'm adding. So I'm going to put a plus sign between all of this. What goes here then? 0, because it's just nothing. So what's 3 plus 1? 2 plus negative 10. Thank you. I was worried for a second there. Negative 1 plus 0. Negative 7 plus 8. Done. Okay. The weird one will come into play because you'll forget about the distributive property of the negative when you have subtraction. Do the exact same thing. When I have a subtraction style problem, don't write it horizontally as you're starting to write this down. Right away, put it in descending order vertically. So write out your 5x squared plus x minus 7. Notice, again, that I spaced it out a little bit. Made it a little bit wider so I have room to see what's happening. Put the values that match underneath. 3x squared minus 6x minus 1. And now between all of them, I'm going to put a subtraction symbol, which basically just means I've turned this problem into 3 subtraction problems. In essence, distributing the negative to all 3 terms without forgetting how to do that. But it's a little trick. So now all you have to do is 5 minus 3, 2. 1 minus negative 6. Negative 7 minus negative 1. Bada bing,
Dang.
That was Italian. It's from The Sopranos. I was in this. Bada bing, bada bing. You're right.
As far as I know.
Got all of them, but thanks for this.
It's the same, but it's.
I feel like you should go get some chips. Say that.
What kind of some
Multiply. Multiply. When you are doing the multiplication, now we're not just foiling, because here I have a binomial times a trinomial, which means I'm going to use the distributive property not once, but a lady. Why are you leaving your stuff all over the place? Sick and tired of cleaning up after you. Should be.
True.
3x cubed, 2x squared. What are you going to forget about here?
The negative.
The negative. When you're distributing out, don't forget it's negative 3 times all the parts. There's 9x squared plus 6x plus 12. No, I don't know what to do. Please help me when I work with a polynomial. What should I put first? Well, I don't know. What?
The cube.
Why?
This is the biggest descending cube.
Boy, learn something. So we start with the large heart. And now I've written it down, so I'm going to cross it off my list so I don't accidentally write it down twice.
Have you done that before?
Maybe. Next one would be the squares, right?
Yeah.
So let's find them. Here's one, here's the other. What's negative 2 minus 9?
I feel like I'm watching Dora.
Okay. Next, I have to go to the value of x. Where are they? Here they are.
Now I get what he's saying.
I don't get the reference.
Here they
They
are.
always point everything
Oh, I didn't know that. My kids don't watch that.
Good.
Good. No, if it's not Wildcrats, it's not on my TV. Am I right? What if?
What about Go Diego Go? What about reading Windows?
I'm not gonna lie. For some odd reason, my children really like Wildcrats, and for some weird reason, all of a sudden, Curious George is like the bomb. I don't know why. I never really did either, but my 6.5-year-old is like, yeah, he's pretty cool. I'm like, okay, whatever. It's
He's a
harmless.
monkey.
He's a monkey that gets into trouble because he's curious.
You don't watch SpongeBob?
Who?
You don't watch SpongeBob?
No.
Oh, wow.
Good.
I don't
They watch Scooby-Doo?
Do this one.
That's like all by myself.
That's just the show.
All by myself. Yes.
Did your voice just...
It might have.
I heard that.
It's tough getting to be my age. Notice in this one you're going to trinomial times a binomial. Does the order in which you multiply matter?
Probably.
I'm not. Would it be easier to multiply the 2x plus 1 into the 4x squared, or would it be 4x squared into the 2x minus 1?
First one, minus 1 and
So what would you write down first then? Maybe I would do this as I'm writing down my problem. What? It looks good.
In mirror.
Here, girl, get a beer.
I already have everything down, though.
Can you try that?
What's this?
I can read it.
Okay,
Yeah, it works.
Yeah, it works. What are you guys worried about? Good luck.
This is gonna end well. You want me to shut down? I can help you.
Yeah.
How about a little more?
Oh my God.
A little more?
No.
It's like good.
Oh, wait. I can't do this.
I tried.
But what I'm saying here, guys, is when you get to a problem like that, write the smaller one down first, because it's easier to go that than
Can you please put this back? Well, I
just
wrote-
look sideways. You'll be fine.
I wrote mine like
What I'm saying is, I would write this problem down like this. Oops, for not forget the wall. Because to me, it seems easier to send 2 things in instead of sending 3 things in. But it's kind of this, it's the same thing no matter what, but it just seems like it would be easier. That's the only reason why I say to write down that the smaller of the 2 terms first. Other than that, it's really simple. So let me give you some more problems.
oh, I love what we do. Except when you have to
How do you not like my singing?
Do not throw that.
You guys are all.
Yeah, we're haters. We're not the haters.
Quit looking for it. I found it. Your fault. You stole it, you jerk. Don't wanna be all by myself. So let's see, section 6.2, page.
What is this?
Minus 9, actually.
Wait, what's the U? Like,
Even.
oh, that's a U.
That's
Oh, shit.
You gotta save for the possibility.
Okay?
Every third.
We will, I'm going to show you guys a little bit about special product stuff tomorrow. There's a couple patterns that happen that makes life really easy and you can get your attention on them. So, every third problem would be 21, 24, 27, 30, 33, 36, 39, 33, and so on and so forth. Oakley dokley?